So, let's start. Hi, welcome everyone. I'm so happy to be here and talk about our incredible approach to process and visualize the big data of our end customers. We are Vattenfall, one of Europe's largest energy and heat providers, and we have been working with web applications for many years. We are proud to be Microsoft partners. Microsoft has announced 2 new data centers in Sweden. We will help Microsoft in the sourcing and supply of green energy. And Microsoft helps us with their expertise when we build modern performing web applications. In this session, we are going to look into our requirements and challenges when we build our web applications. We will go through our data flow. We will look how we built our model in Azure Analysis Services and see how we embed PowerBI Reports into our web application. We will talk about authentication flow and security. Before we start, how many of you have heard about PowerBI Embedded? Great. How many have used in production? When you go from here, you will think, that's awesome. That's something I want to try out. That's something that can help me to visualize my big data for my customers. If you got any questions, please find me after this session. I will be happy to chat. My name is Irina Dragunova. When I was small, I liked to draw princesses. Then I studied applied mathematics and computer science and worked as software developers for many years. Currently, I work at Vattenfall as solution designer, and my creativity helps me to design and build complex web applications. I love art. I use every possibility to visit an art gallery or photography exhibition. You can think about masterpiece. It's so simple. Clear idea, realization. I understand it perfectly well. But every masterpiece is a result of human imagination and creative impulse. It tells a lot about the artist's personality and ways of seeing the world. Think about how much time the author has spent on this masterpiece. Years of mastering, education, hours of hard work, maybe some sleepless night. I believe the same with software development. If you see some project as simple, it means it's a good, well-designed and well-orchestrated solution with hundreds of hours of hard work behind the scenes. I love to work with complex solutions, and I still like to draw. I sketched this presentation myself. Currently, I am working with district heating. Not only. I am working with a bunch of amazing people, really very skilled developers and nice people. And we build web application for enterprise heat customers. And this is district heating. District heating is several hundred thousand kilometers of pipes below under feet, under the ground, transporting hot water to more than half all residential and industrial buildings in Sweden. Vattenfall produces district heating from what otherwise would go to waste. Our usual waste, surplus heating from industries, data centers, wood from building sites, everything. So it's a very environmental friendly way of heating our buildings. This is smart meter. I just like my drawing. Actual smart meter looks like this. It sends back to Vattenfall hourly measured consumption flow temperature data using the mobile networks. Since many years back, our customers have been equipped with smart meters. Vattenfall is running district heating in several locations in Sweden, and we have also customers in Germany. Do you think how many rows we have in our database? 10,000? No, not even 100,000. Currently we have 1.4 billions of rows. Think about it. It's a huge number. And this is awesome. This is really a huge opportunity for our company. We can extract real value out of it. We want to visualize this data for our customers, of course. We want also to show our in-house expertise and apply powerful analytics on top of it. We want to run machine learning algorithms, do predictions, and much, much more. It can help our company to build trust with our customers. We want them to stay with us. We want also to attract new customers. And our digital solutions is a great possibility to do it. Our customers are large enterprises. One parent company can have multiple subsidiaries, can be hundreds. Every subsidiary can have many, many installations. And every installation has a smart meter, sending data hourly to our company. And our customers want to have full control over their consumption because it's a huge cost for many of them. We gather data on hourly basis in Sweden. Our German smart meters send data every 15 minutes to our company. We want to visualize this data on hourly basis for our customers so that can easily see trends and peaks if something goes wrong. We want also to be able to aggregate this data on daily, monthly, and yearly period. Our traditional approach was that we gathered all the data in one storage, in one SQL database, and then used REST APIs to show the data in the web application. The problem was that SQL database just couldn't handle that massive amount of data. Of course, we could create aggregated views per installation, per time resolution in SQL database. It's a huge development cost, and this solution is still not good. Our customers want to see the information very quickly. Response time shouldn't exceed 2-3 seconds. And sometimes what they could see was, and after 2 minutes of this nice screen, when they requested data for longer time periods with high time resolution, they got this. Why? Because our services just couldn't handle that massive amounts of data. We try to solve this problem in many possible ways. We try to apply cache, different caching strategies, different layers, even more and more cache. What about maintainability of this solution? Reliability, stability, transparency. I celebrated my birthday once, had really amazing cocktail party. When I came to work next day, I noticed that product owner was in panic. What happened? Nothing is working in production. What do you mean by nothing? Just nothing! Monday morning, cocktail party the day before, issues in production. Not a good combination. I started to troubleshoot. Yeah, sometimes we all need this troubleshoot. At the end, I could find the issue. It was issue with one cache. I fixed it. But of course, we needed a better approach for our solution. Let's recap. We have some challenges. We have really complex data structure. We have data on hourly basis. We receive our data from different and slow sources. And our application should visualize this data on hourly basis for longer time periods. This should be done very fast. Response time shouldn't exceed 2-3 seconds. And we work with large enterprises. This solution should be very scalable. We should be able to put more users without affecting the performance. And all the users should be able to log in simultaneously. So it should be adapted for concurrent use. What if we had just one service which could handle all our data instead of all these small caches and different databases? Then we can build our model in this service and visualize in web application. That's good. We could get really good performance. This solution could be very scalable. The only issues left, we still need to present our data in our web application. What if we had some tool to visualize this data also and embed it in our application? It could solve all our issues. Almost 3 years back, one of my amazing colleagues came up with one idea. What if we use Azure Analysis Services to build our model? This is really great tool. This can handle massive amounts of data. All the data is pre-cached and stored in memory, and we can build really complex queries to handle the data and present in the web application. And it can scale up to 400 gigabytes of capacity. That could fit really well our needs. And then we used also Microsoft PowerBI to build our reports and dashboard. This is business intelligent platform for data visualization. To use this, we need PowerBI Pro or premium license for our organization. Then we can build the reports, and it can be easily integrated into web application without requiring end users to have these licenses. And this is PowerBI Report. When I saw it for the first time, you remember I love art and creativity. I have been working with front end for many years. I was a bit like, can it fulfill our needs? Is it really nice? We can build much better solutions in front end. But then, when I started to work with it, I realized we can use any possible colors with this tool, so we can easily adapt it to our brand standards. We couldn't use our custom font, which we use in our company, but we could use any standard font together with this tool. And what is the greatest thing with this? We can show as many data as we want. This tool doesn't have any restrictions. This is iframe, and we can easily embed it into our web application. And this tool, this is built with visuals, and every visual can be highly interactive. If you click in one place, you can see that it could affect everything on this page. If you have complex data hierarchy, you can drill down in one report and see the changes. And this is how PowerBI Desktop looks like. this tool where we build our reports. This is drag and drop functionality. First, what you do, you need to connect it to your model. It can be any source, from CSV and Excel files to databases, Azure Analysis Services in our case. You see your tables here. You drag and drop your columns into this place. Then you select a visual and you see the result here. That's it. And Power BI has a good set of built-in visuals, really different charts, diagrams, everything. If it's not enough, there is Power BI Marketplace. There you can find both free and paid visuals, which we can use how you want. And Power BI Reports can be easily combined in one web application with other front-end libraries. So you see some examples from our applications. I'm more than sure if I ask you where is Power BI Report and where is not every one of you will answer correctly. Here is the answer. Ladies in red, this is Power BI Reports, and blue ones, these reports are built with other front-end tools. And this is how our application looks like today. As you can see, this is not only Power BI Report. This is our lessons learned. When we start with our pilot project, first we thought like this. We put everything into one report. Filtering, grouping, company structure, everything. Simple, easy. It is not. So for better user experience, we try to put in Power BI Report only these things Power BI is especially good for, visualizing big, large data sets. So this is Power BI Report. And then we moved outside of Power BI everything that could be moved. This is company structure. We do the selections, we do filtering, we show it immediately the result in Power BI. This is time resolution picker, date picker, export functionality. All these things are outside Power BI. Let's look into our architectural approach. This is how our architecture of our application looks like today. We have historical data in our system, such as information about installations, addresses, contract information, invoices, which we take from different data sources. The data comes first to Azure Data Lake Storage, where we aggregate and clean the data, apply some necessary transformations using Azure Databricks. Azure Databricks is a data engineering tool used for parallel processing and transforming really massive amounts of data. Then we save all the data in our SQL database. We use Data Factory here to orchestrate all this project. Some data, for example weather data, comes directly to SQL database. Then we have some near real-time data, which we get from Germany. We have a job which takes this data every 15 minutes and transports to Event Hub. Event Hub can handle millions of operations per second from any source, and the Web Hub triggers Azure functions and transport the data to the same SQL database. As we have all this data in one place, we can easily do some cool stuff. What I especially like in this application, we do some predictions. So we built a pipeline which takes the data from Azure Database per installation. We save it in Parquet files in blob storage. Then our machine learning services picks up these files, and in machine learning services we run our models, we do some predictions. What we do, we predict heat consumption for our customer using weather data for shorter periods, and then without weather data for 1 year on daily level. This is really great. It brings a lot of value. Then we save our results back to our database, and then we build our model in Azure Analysis Services, a cube. Cube is a multidimensional structure that contains all the data. Single place where all related data is stored. The data is highly compressed. The data is in memory. Every time our data is updated in database, we have logic up which says, hello, we got new data, and it triggers cube update. Then Power BI works really good with Azure Analysis Services. We visualize our reports there and publish it into our web application, and some data we just pick up with REST APIs as usually and presented web application. So let's look into some technical details, how our data flow looks like. In our organization, we follow modern data warehousing concept. We have Azure Data Lake Storage. There comes all the data we have. IoT data, PDF files for invoices, CSV files for consumption, everything. Benefits, it is cheap, and all our projects within the whole organization can share the data across each other. Then we use Azure Data Factory service to orchestrate ETL process, extract, transform, load. We load all the data file by file, first to staging. It can be very small files from different sources, for example, energy consumption for one installation for 1 month. So we need to put all these files together, do some initial cleaning, then we bring this data to row. Then, when we aggregate this data in row, we apply some business transformation and put this data in BTL layer. We use Databricks here. Databricks can do parallel processing of data, so that happens very fast. Now we continue with traditional BI approach. Do we have any BI developers in this room? Good, you can close your ears and relax for a minute. After processing the data in the business transformation layer in Data Lake, we transport all the data into SQL database. Why do we do it? We use SQL in this case as temporary storage of hot data, because there is no way to transport the data immediately to Azure Analysis Services. Then we built our star schema in Azure Analysis Services. Just to recap, the star schema separates data into fact tables and dimensional tables. Fact tables hold all the quantitative data about the business. Dimensions have some properties, attributes related to fact data. It looks like a star with a fact table in the middle, surrounded by dimensional tables. In our model, we have 4 fact tables, for example, with consumption data, invoice data, and installation data, and then also around 15 dimensional data containing information about addresses, zip codes, streets, dates, times, weather data, and so on. Dimensional table usually contain very small amount of data, and fact table are really huge and continue to grow over time. All new measurements come to fact tables. That's why it's really important to consider possible performance implications when building this model. For example, dimensional tables shouldn't have any duplicates, any duplicated data. All the keys should be integer, not strings, to save memory. It takes less space. What else? Data should be pre-aggregated to this level we need to show in our web application. If you don't need to show data for hourly consumption, for example, only for daily, we should pre-aggregate the data and store on daily basis. And then we need also to send only the data that is really needed to our views. This is obvious. How it works then with Power BI? Power BI generates queries and this sent to the model. These queries are used to filter, group and summarize the data, and it fits really well to star schema model. Well-designed dimension tables provide information for filtering and grouping, and fact tables used for summarizing. And we can build PowerBI Report on top of it. So we got the data, built the model, created the report. Let's look how we can embed the report into our web application. We use JavaScript library, official library provided by Microsoft. So we need to include this library into our page, and then we need to create some HTML element which will be used to embed this iframe. Then we take reference to this element by ID and embed report into this element using embedded config. If you prefer to use TypeScript, you can use pretty much any TypeScript library for any front-end framework. As we use Angular, we use this library built on top of official Microsoft Power BI client. Some tips here. Keep tools and packages up to date. Power BI is really a very new functionality, and Microsoft releases updates every month, so keep an eye. To improve end user performance, if you don't embed your report on first page, you can still preload all the JavaScript and CSS files in the background. So then you can show them faster in your application. If you want to measure embedded performance, there are some events provided by this library. You can watch loaded, rendered events and so on and see how fast it's loaded. So, everything clear until this point, except one thing. What is config? And config consists of some properties. Settings are used for localization of your report and also to show and hide some report elements in the view. Filters are used to filter data in Azure Analysis Services. For example, by installation or by date permissions. There are two types of embedding your reports depending on your authorization method, and also if your users have Power BI Pro license or not. And this is the most important part. It will let Power BI know which report are you going to embed and if you're authorized to see it or not. Your report can have several pages shown as tabs here. Every page has pre-aggregated information. We build it in this way, so we have one page for every time resolution, year, month, day, hour, and also for every language. You see Swedish and English here. Of course, we don't need to show this panel in the view. And here is live demo. I love this demo, really. It's a new way of showing the data. No demo ghosts ever. This is animated GIF. You see, I select time resolutions. I switch from hour to day, month, and year. And the information is updated really fast in the view. It's a real demo. It's amazing. How we can filter our data in the view. JavaScript library has really powerful mechanism to filter the data. There are different types of filters you can send to Azure Analysis Services with your JavaScript library. Basic filter will filter the data by column in your table. You can use it to filter installation data or aggregate for multiple installations or other things. Advanced filter sets the range in which the data will be shown. So here I filter consumption history and want to show the data only for January. Very easy. Live demo. Just to recap, our customers have really complex hierarchy with parent company, subsidiary, and installation level. In our application, only with several clicks, they can deep dive into the installation level consumption and see the result, or aggregate the data for multiple installations for subsidiaries, or benchmark against the market segment really, really fast. Good. Let's look into embedding models. We include our report in our HTML page. Now we need to select an appropriate model. Everything depends on two things. If you authorized your users with Azure Active Directory or not, and if your users have PowerBI Pro license or not. User owns data is the simplest form. It means that your users have access to your reports outside of your web application. They should have PowerBI Pro license, and they should log in into your application using active Azure Directory token, Azure Active Directory token. This scenario is mostly used if you develop application for your internal users in your company. Application owns data. In this model, your users don't have PowerBI Pro license, and they can use another method to authorize in the web application, not necessarily Azure Active Directory. This scenario is commonly used when you develop application for your external users. This small slide actually was the biggest cost for our pilot project. We went back and forth until we completely understood how these embedded models work. So first we developed application with app-owns data scenario. Our security didn't approve it. We went to user owns data, redeveloped authentication mechanism. Then we got issues with external users trying to federate their Azure Active Directory token and log in into web application. It didn't really work very well. We went back to app-owns data scenario, and this time we developed it in proper way. I will explain how. So what do we need to embed the report using app-owns data scenario? First of all, we need to have Azure Active Directory tenant for our organization. We need to register our application there. We need to give our application PowerBI permissions. Then we need to create service account, which will be used to authorize this application to Azure Analysis Services. And then we create a workspace in PowerBI, put all our reports there, and our service account should be admin in this workspace. Authorization. Our application needs two different authentications. First, we need to authenticate to web application, then we need to authenticate to Power BI and Azure Analysis Services. User starts session with our application and is redirected to OpenID provider, which we use in our application as a standard. OpenID provider authenticates, authorizes the user, sends back one-time use code. This code is passed together with user credentials to OpenID provider's endpoint. Then this code is validated and we get back GVT token with our custom claim, which is called access role. And this is what we use to ensure security in our application. Let's talk about security in our everyday life. When I say security, what is first that comes up to your mind? Problems. What about seatbelt? Seatbelt dramatically reduces risk of death and serious injuries. How many of you use it every day? Stupid question. Do you know that seatbelts was invented in Vattenfall? When Vattenfall realized in late 50s, last century, that the amount of accidents is dramatically increasing, they started to look into this problem, did some investigations, crash tests, and two of Vattenfall engineers invented what was called the Vattenfall diagonal belt. This was presented to Volvo, and Volvo was the first car manufacturer to implement it in their cars in late 50s. And until mid-60s, this was standard in Sweden and some other European countries. Security is also our main requirement when we work with our web application. As we work with customer data, we just cannot afford data leaking somewhere. So let's look how we implement our security. We get our custom claim access role from our identity provider. We have a table which has one-to-many connection to customer IDs, and this is used to what is called row-level security. This is built-in functionality in Azure Analysis Services. It restricts customer data access to only that data that's relevant only for this particular user. These access restrictions are applied every time the data access is attempted from anywhere. This makes really the security system very reliable and robust. Now we need to authenticate our application to Azure Active Directory using service account. We retrieve it from Azure Key Vault, authenticate, get back access code, and this access code together with our custom claim is sent through Power BI back to Azure Active Directory, and we get back the embedded token. And this embedded token we send to Power BI to request report data, and we get back what was missing in our config, the only part which was left to embed our Power BI web application. That's it. Power BI report is embedded. Let's just take a quick look into our process, how often we load the data, what our processes. So every night at 2 o'clock, we have a batch load which loads the data, refresh the data for last 40 days. This is our business requirement in our organization. And we do incremental load. We update the data only for last 40 days. We don't do full load every day, of course. This is unnecessary and very inefficient. We do it only if we refresh the environment. Costs. Both Azure Analysis Services and Databricks are really great and can perform really complex operations really fast, but they are also very expensive. So we try to use them in a smart way. We implemented, created PowerBI Reports to look into our costs. Our Databricks costs only when we use it. 20 minutes, half an hour per day when we perform incremental load. Azure Analysis Services bills on an hourly rate. And the price depends on service tier and performance level. So of course, our production environment should always work with a very good performance. But we have 3 other environments: development, test, and acceptance. So when we stop these environments, it doesn't cost anything. So we implemented a job which stops all the 3 environments during nights and weekends when no one works. It helped us to reduce the cost immediately with 60%. So let's wrap it up. What are the benefits of our approach? First of all, it tremendously improves our user experience. Our customers can get insights into their data very fast with really good performance. We did some measurements. Our application performed up to 30% times faster than other applications in our organization. It's really amazing. And if we add more customers, our model can handle it. It is scalable. It will not reduce the performance. Then our reports can be created really fast. When we get new business requirements, when our requirements change it, we can do the updates without redeploying the whole application. According to our estimation, we can deliver now up to 5 times faster. And Power BI reports can be seamlessly integrated into existing web application. Built-in security, everything is maintained by Microsoft. The cost of our first pilot project was 10 times lower than the cost of similar project in our organization. Take it home, think about it, try it out. Maybe it's something that can help you to visualize your data. And thank you so much for having me here. It was a great pleasure for me to be and talk in front of you. Thank you.